These are notes about molarity. So molarity is a way to calculate the concentration of something. So how many moles of solute, what's getting dissolved, can be dissolved per liter of the full solution. So this is really common to use molarity in chemistry. So in molarity, the unit is big M. So let me just show you. So if I were to do this calculation, and let's say I have 1.5 moles in 1 liter, so then when I divide that, my molarity would be 1.5 mole per liter. The units don't cancel. And then we use the capital letter big M to be the unit for molarity. So it's a little weird. You're solving for big M equals moles over liters of solution. But just realize that you're solving for it, but yet it is also the label and it belongs at the end of the number. The other thing is that the volume has to be in liters. So in our calculations, there's times where your volume could be in milliliters, and I'll show you how to do one of those conversions. So here's an example, like if I had the volume in milliliters, you can, and I have the work below, but I just want to show you. If you remember, we can do this with dimensional analysis. As long as you remember that there's 1,000 milliliters in a liter, so then I can make a conversion out of that. I can put my 1,000 milliliters on the bottom, 1 liter here, because I know those will cancel. And then essentially you're dividing by 1,000. So you can just remember to divide by 1,000 if you have the volume given in liters, or that you're just moving it 3 to the left. We are going to be doing some mole conversions with molarity because it's moles per liter. There's times where I will give you the mass instead of the moles and you'll have to go to mole. So we'll be doing this conversion again. So let me show you that. So here would be an example. If I had 140 grams of sodium chloride and I wanted to go to moles. So I'm starting here at 140 grams and I want to go to mole. So I'm going to want to use this conversion where I have 1 mole over, and then I want to get the molar mass. So if you remember, molar mass is those average atomic mass numbers. So on your periodic table, sodium is 22.99 and chlorine is 35.45. So that's how we get the molar mass of sodium chloride, is by adding those. So if I take that fact that 58.44, there's that many grams in a mole, when I added the 22.99 and the 35.45, then I can set that up as a conversion. The grams cancel and I'm in moles. So those are just the 2 steps that sometimes you'll have to do to get to moles or to get to liters. Some of the problems are really straightforward, like this one. So they want molarity, which is moles per liter, and everything's in the right unit. So 4.5 moles over 0.875 liters. And then when we divide these, we get 5.1. And the unit is mole per liter, or we could say 5.1 capital M. Here is a, did I fix that yet? Okay, I might have to fix the slide on here, but I think I'm doing okay. So we know that molarity equals moles per liter. So we can solve for anything here and do the algebra. So if I were to want to have the volume in liters, then I would use this formula. And if I want to know the moles, I would take molarity times liters. So here's another question. You're wanting to make 1.25 liters. So sometimes I just start with the equation and I start subbing in. So I want 1.25 liters as my volume. And I know the molarity. So I'm kind of making, let me see. So if I were to plug in my molarity over here, let's just ignore that. Molarity equals, my moles are missing over my volume in liters. So let me rewrite that over here. So 0.5 of molarity equals moles over 1.25 liter. So to do the algebra, this is my x. You can do it however you do your algebra. I put this over 1 and I cross multiply so that I don't end up with anything in the denominator. So I'm taking molarity, which is moles per liter. You can leave it, but when you do it this way, you can see then that your liters cancel and that you did it correctly. So when you multiply the 0.50 times 1.25, you get you'll round it to 2 sig figs, 0.63 moles. And back to this question, they want to know the moles, but they also want to know grams. So again, I'm just going to show you the mole map. So we got the moles, but now we're going to go out to grams. So I'm going to just start with a new slide so I have more room. So in the previous slide, we had, we had determined, I think it was 0.63 moles, right? So 0.63 moles of sodium chloride, and now you're going to go the other direction. So 58.44 grams of sodium chloride. Remember, that was by getting the 22.99 and 35.45 from the periodic table per 1 mole. So the moles cancel, so you're just multiplying then 0.63 times 58.44, and you end up with 30, it rounds to 2 sig figs, so 37 grams.